Hi everyone, I was going to show you how to do the Lewis dot easy today. It's pretty simple. I'm going to go ahead and get you guys started. So this is day 3. I will have this video up here, so I would recommend watching that first. So what you'll need is the periodic table and you'll need the Lewis dot structure. Okay, the cool thing about this worksheet is that it's already done for you. Okay. What I mean that it's already done, they already have the periodic table. Now, what some students complained about with the other one, I do want to keep it on Google Classroom this time, and I'll show you why here in just, or Google Slides, and I'll show you why. You can blow it up so you can see, and they don't have the symbols because we don't need that. What we need is just the group that they're in, because we spent a great deal of time trying to explain that a lot atoms within the same group or column or up and down, function here are very similar. So helium, neon, argon, krypton, xenon, they are all noble gases. They do not react with anything except xenon is a rarity. And you'll see what it has to do. It's kind of cool. It's used in flash photography and some sunscreen type stuff. Um, excuse me. Fluorine, chlorine, bromine from week 3, day 3. You guys saw that is highly, highly toxic. Mustard gas, bromine had a really bad reaction to with my eyes with that. And then iodine starts getting a little cooler because it starts getting pretty heavy, but that's what kills bacteria. Chlorine we use for water, and fluorine is pretty nasty. Okay. And that's because they're very reactive. They have 7 valence electrons and they want to be the noble gas, especially fluorine is so close to being neon. But it's not neon. Neon's content, fluorine isn't. Okay, so what you guys are going to do, and I'll show you here in just a second why we do this. I'm going to pause it for a second. Okay, so I'm going to start off with just showing you how to do it. So I'm going to make an element. There is no element named X. Okay. And when we do the valence electrons, we look on the rows of the periodic table. So I'm going to go ahead and pull up the periodic table. We do not consider the transition metals here, the D block part of that. And we'll learn why. Well, you kind of already learned that there's just so many. This goes up, down, up, 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 down, down, down. If we were to throw these guys or these guys, it just would be chaotic. So I do get particular on this. I'll be a lot more flexible because of online learning. But if you were to write this like electrons and go 1, 2, 3, 4, 5, 6, 7, 8, meaning if I were to have neon, or let's say actually element A, and I just went like this for 4, you kind of would get laughed out of the room. So I don't want that. I want you guys to have some chemistry skills getting out of here. So it's kind of like what you would do. You go up, down, side, side, or north, south, east, west. And then you repeat it, north, south, east, west. Not very religious, but and I'm not Catholic, but it's kind of if you're doing the sign of the cross. You go up, down, side, side, up, down, side, side. It's just the easy way that I remember how to do that. Okay, so I am going to start with the element strontium. It is Sr. I'm going to look on the periodic table. I'm going to get a little wordy here, but it's right here. So it is past 1s2, goes past 2s2 plus 2p6, so that's a total of 10. Then we go 3s2, 3p6, so that's a total of 18. 4s2, 3d10, 4p6, so that's a total of 46. and then we go over to 5s2. Okay, and that 5s2 because krypton is full. We're happy with krypton just being where it is, and we're not concerned about it anymore. All right, those are all full, but this is still pretty reactive in the sense because it has 2 valence electrons. If you guys remember from last time and even last semester, that strontium actually can replace part of calcium when it's making bones. It doesn't like to do that, but it does because it has 2 valence electrons. And plus, there's not a ton of strontium in our environment to do that in comparison to calcium. Okay, so give me a second and pull up. Now, I saw that it was in column 1, so I'm going to follow this. This is not correct. You do not want to do it this way. You want to go 1, 2, 3, 4. Like I said, north, south, east, west. 5, 6, 7, 8. Miss Kaufman, can I kind of put 3, 7 up here and 1 and 5 on the side? Sure. That's not a problem. You just don't want them grouped together because remember, they want to go up, 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 and then down, down, down. And that is, I enforce that because it gets, when we start bonding and making molecules, it makes a lot more sense, okay? So strontium has 2 valence electrons because it's in the group 2, right? And you just go side, side. Can I do it like this? And I'm going to tidbit you, this is actually wrong, but I'll talk about that later. Maybe an extra credit thing. 1, 2. Can I use dots? Yes, since it is Lewis dot. Excuse me. I use hash marks. I just think that they're a little easier and I don't have to have them so pretty. And I can tell if it's 1 hash mark or this might be 2 circles. Okay? Hey, Amen, give me a number. Oh, 15 it is. So that is phosphorus. Now, if I were to go look at phosphorus, it is in group 15. So 1s2, 2s2, 2p6, 3, 2p6, 3s2, 3p, 1, 2, 3. Okay, let's check that again. 1, 2, 3, 4, 5. Again, I'm not concerned about these guys because the energy level's filled. I'm concerned about the valence electrons, and we have the S and we have the P's. So 2, 3, 4, 5. 5 valence electrons. I'm going to go ahead and clear this, okay? Except for this guy over on the side, or element X. Properly done. And stay at the end because I'm going to show you how to do it on your assignment. So P is, or I'm going to do it in another video. 1, 2, 3, 4, 5. Miss Kaufman, can I put it here on the side? Yes, but it doesn't really matter. I just know that this is called a lone pair. And that's why ammonia is ammonia, because it has this lone pair on the top and it kind of takes up a lot of space. And so you get this weird tetrahedral, like pyramid looking molecule. So this guy is called the lone pair right here. Okay. And then these are just valent, the other valence ones. All right. I'm going to go ahead and close off this video. I'm going to add another one. So if you guys felt comfortable on this then you didn't have to come and, or you can go skip on to the other one. Okay. All right. Thanks for joining me. If you guys go to the next video, I'm going to do 2 of these. Okay. 2 of them. They're actually doing them in order, so fairly simple. Okay. Now where are we?